Okay, so welcome to week 2 of the CREO tutorials. So, we've got this frame again. One thing you can do with holes like this is you can put a bolt through them, a threaded fastener, which is what you should be covering in your week 2 material. So, this week we're going to cover how to use helical sweeps to create threaded fasteners. Can also be used to create worm gears. Little side note. So we're going to start a new part. New, we want a part 2, that's fine. So again, we've got the datum planes. We're going to start with a sketch because every bolt has a body. Circle. I don't even remember how large I made that on the other one, doesn't matter though. Let's say if we want a 60mm bolt. Bit large, but yeah, it'll work for our purposes. Then we're going to extrude. Now, to make this recognizable as a bolt, if you're going to practice with this example, I would suggest you make it in roughly a 10:1 ratio. So if I make 60mm diameter, I'm going to make it 600mm long. And accept. Okay, there's the body of the bolt. Now, the command that we want is a sweep to create the threads. So you see how I've got the sweep button here. Open the drop down menu and select helical sweep. Now this is a bit of a fiddly command. There are 3 stages that you need to specify in order for this to work. So the first thing is the helix sweep profile, which is the profile along the bolt over which you want the threads to be repeated. So when you go to select a plane, make sure it's one of the longitudinal planes going along the bolt. I'll ask you to select one, just select it and hit sketch, and go into sketch view. Now, to define this, all you need is a line, just one line that starts where you want your thread to start, usually at the end of the bolt, and ends a little bit further up. So I'm going to leave a little bit at the top here because some bolts don't have threads the whole way up. I'll just make it look a little bit prettier. You can go the whole way up if you want. You can go up this far, go up this far. Really depends on what you're designing the bolt for. And then just hit OK. That's all you need to do for the first sketch. Then we need to select the helix axis, which we want to be the central axis of the cylinder. So I would suggest, because I've come across this issue a couple of times, when you go to design a bolt, draw your initial circle exactly on 0, 0. On your initial sketch plane, which if you haven't done, I'll show you how to do shortly. So we've selected that. Now we want to do a sketch, and this sketch, I'll just show you again where that button was, up here says create or edit sweep section. So by that it means effectively the thread profile. So then you'll see these 2 dotted lines come up in a cross. We want to go down to where they intersect. Again, sketch view makes this a little bit easier. Okay, say I want a triangular thread. All I need to do is make a closed shape. Now, in CREO, if you do a sketch, hit escape to accept, and you see this pink shading come up, that means that your sketch is closed, which in simplistic terms means CREO's happy with it. It'll do an extrusion of it. It basically means that you have one external line that is completely connected. You have no gaps in that line, and you have no lines inside of that. Now, if you have one complete line inside of another complete line and there's no intersection between them, CREO can treat that like a torus. So you can effectively have a void inside of your sketch. I'll show you that in a second. We'll just do the thread for now. So all we need to know is pink inside, CREO thinks it's good to continue. So we'll hit OK, and you'll see I've created a thread all the way up to the top of my helix profile, which is shown by this green line. Now, if I want to adjust the pitch, I can make the threads more or less dense, depending on what I want. So if I go for, say, a 10 mil pitch, it's going to fail to regenerate. So if it fails to regenerate, it basically means you've overlapped your threads. So let's make that a little bit wider, spread them out a little bit more. There we go. So 20 mil it's happy with. And 30, yeah. So you can see by adjusting the pitch, you can increase or decrease the density of threads on your bolt. I think 15 is about what I want. Yeah, that looks good. And accept. Okay. So I've got threads. Still doesn't look quite like a bolt though, needs a head. So let's select this top surface, do a sketch. Okay, now if I want to do a hexagon, it's a little bit tricky. There's no command in CREO to create a hexagon. So what I'm going to do is I'm going to go into construction mode. Now what that means is any lines that I draw while construction mode is active aren't considered part of the sketch for future purposes. So you'll see I'll draw a circle and it'll come up in this dotted line. Effectively that's CREO saying, okay, you've got a circle there, you can use it for all references in this sketch. As soon as you close the sketch, it no longer exists. Now, I'm then going to draw a rectangle. So this is a neat little trick on how to draw hexagons. Now I'm going to turn construction mode off, select line, go across, and around. And voila, there is a hexagon. Again, you see it's pink, so it's good. CREO likes it. So, now if I want to make a void within that, whilst keeping it a closed shape, what I can do is, let's say I want this for an Allen key. So we need another hexagon inside. So we'll do the same thing again, create a circle, create a rectangle, exit construction mode and go to line, left click, left click, left click, left. That wasn't terribly good. Let's try that again. Okay, there we go. So now you see it's no longer pink inside here. So what that means is that this pink area is what CREO is now going to accept as the inside of your shape, bounded by this external hexagon and this internal hexagon. So you see what I mean? I'm going to accept that, so just hit OK, then go extrude. So CREO's only taken that pink section to be my sketch, and only extruded what was inside the pink section, not the clear sections. And accept that. Okay. So there's a bolt. So what I meant by offsets from the origin, and how you can fix those is if I go back to my original sketch. So right now that's just a circle that you can see is centered about the origin planes. Now if I were to draw a circle out here, you can see I get all these blue dimensions showing up. So you got the diameter, yeah, that's normal. You've then got this offset, which you see measures the distance from this origin plane, and this offset that measures the distance from this origin plane. If you did this, don't worry, your helical sweep might not work. It's something to do with the way it likes to generate axes, but you can fix that. All you got to do is select each of your offset dimensions and just set them to 0. So this one, set it to 0. There you go. Now if I accept that, I'll actually have made a hollow screw. Anyway. So, one more thing before I finish this, oh actually 2 more things before I finish this up for today. So, a little trick in sketching, which can just help you clean up complicated sketches. Let's do this with a new part though. So, File, New Part. So, if I want to make a pillow block for a bearing, sometimes they've got a bit of an odd shape. I'll show you the way I like to do it. So we're going to do Sketch. I'm going to start off with a rectangle. Yes, let's enter Sketch View. That's going to make it a little easier. Let's say 300 wide, 150 offset, and make it 50 deep. So now I need somewhere to actually put the bearing in, because that's just part of the frame. So I'm going to make a circle. Fair enough, you got to sit it in something. Also probably want the circle to be hollow, so like we just did, make a shape within a shape. They're both closed, so it likes it, it's fine. Note also, you can actually have 2 entirely separate shapes within one sketch. So they're both closed objects, so CREO is fine with both of them. What that means is that if you then go on to do any extrusions, any mirrors, anything that relies on that original sketch, you will utilize both of those shapes. So if I were to select this sketch now and go extrude, I wouldn't just extrude the rectangle or the torus, I would extrude both of them to the same depth. So from now on, they'll act as effectively the same shape. Luckily, I've got more interesting plans than that. So those numbers are fun. Now, if I throw a bit of a spanner in the works, because obviously I want this to be one piece, a pillow block needs to be a single object. Now you see with all of these intersections, it's no longer a closed object. That's a bit of a problem. So, this delete segment command is very, very useful. There are lots of cases where you're going to be designing a complex shape, you're going to get to a stage like this and just go, well, I need to get rid of a few of these. So the way the delete segment command works is it looks at your sketch and it will delete a line between 2 intersections. That can be an intersection with another line, an intersection with a plane. You just got to play around with it. It's a very smart sort of command. So if I've got delete segment selected, I'm going to click on this line. You see it's deleted from the mid plane across to where it intersects here. That's fine. I need to delete a little more though. Let's get rid of this one, this one, this one, this one, this one. Almost looks closed now. I've actually got a few hidden in here. You see there's still 2 orange lines here, so get rid of that one, get rid of that one. Now, because I had a rectangle on top of a rectangle, what CREO has done is it's drawn 2 lines over the same spot. So when you use the delete segment command, then you've got to delete the first one and then delete the second one. CREO doesn't go, oh, they're over the same spot, so they're the same line. It sees them as 2 parts of two separate parts of separate geometries that you've placed down. So delete the second one there. Hit escape. Ah. So you see this section's pink. That's not what I wanted. So note this little red square here. Wherever you see that in CREO, that means something's gone wrong. It means your shape isn't closed. And we can see, if you zoom in, that's because I wasn't entirely correct with how I placed the square. Anyway, so what we've ended up with is these two lines which have gone through and intersected. That's fine, that's what we want. Except I didn't catch it on the end. So we've got this little section sticking out here. So if I go delete segment, I'm going to need to get rid of that. And here we see an example of how finicky CREO can be. Okay. Instead of that, so instead of deleting that segment, because CREO for some reason doesn't want to do that, we'll select this one, delete that, and go line from this corner to this corner. Escape, and now you see this is what we're looking for. Hollow section here, all of this is going to be solid. Hit OK, and then we want to extrude it. Let's go set that depth to 150 mil and accept. Okay, now we're looking like more useful objects. This looks like an actual frame from a machine. So a few little things you can use to clean these up. We don't usually want too many sharp edges like this. As you'll learn from your stress concentration studies, it's not terribly good for the machine. So what we can do is we can use the round or chamfer command, which just add fillets or chamfers in. So there are a couple of ways you can select your faces that you want to fillet between. If you select the first one, hold Control, select the second one. That's one way of doing it. Then same with other dimensions, you can adjust the value just by double clicking. You can also though, if I want to go around again, usually just select the edge between the two lines. And there you go. Now, if you go to do this, and bear in mind I'm just doing them one at a time here, but you can do multiple at a time. So if I select this one, and I select this one, you see it's added both simultaneously. If you do this, and you try to make the radius too large, it will probably fail to regenerate. So you see it's just gone back to a square edge there, but you've still got the draft lines here. It doesn't like that because you're so big that you've tried to intersect with another shape. If something fails to regenerate in CREO, it's usually because either you've intersected it with something that it can't work with. Like here I've told it to fillet, but if I were to actually look at where that fillet's going, it would be up the side of here, and you'd be starting drawing from inside where the hollow section of the pillow block is. That just doesn't work. So it's either usually that or because you've changed a dimension that it was referencing off. But yeah, then sometimes you just need to redraw your parts. So if I set this down to something a little more reasonable, 20, that's fine. Now you see you got that nice smooth shape. Okay. So now if I want to add something to actually screw the bolts into, instead of just having a cylindrical gap for them, effectively if I want to make the mating section of the threaded fastener, I'm going to select this plane, I'm going to draw a circle, and I think they were 60 mil. Let's make this a little bit closer. Let's go 115, that's good. And then extrude to go through the object. Okay, now, it's only on one side here. Pillow blocks, generally, you'll want something like this on both sides to actually hold it in place. Now, if you don't want to go through all that hassle again, and this holds for more complicated geometries as well, you can use the mirror command, because this is done about the central plane. Now, wherever you've got a plane, a geometry on one side, and you want to mirror it exactly on the other, you can just go mirror. Now it asks you for the mirror plane, select that, and you'll see immediately I've got the exact same object on the other side. Useful command if you're doing complicated things and you just want to copy it all. Now, again, this is just a hole. There's no thread for the fastener to attach to. So, therefore, we're going to need a helical sweep. So, same as last time, helix sweep profile. We want it in. Okay. Came across this in class. I just forgot about it here. So, if we're going to draw a sketch, you need a plane to draw that sketch on. Unfortunately, these holes don't actually line up with the plane on the back. So if I were to draw a sketch, you would see the line actually appear on this plane at the back. I'll show you what I mean. So if I go sketch, sketch view, and if I just go along here until I find the edge of the hole, you see it's going to snap to it, because everything's nice and in line. That sketch has appeared at the back of the pillow block. It needs to be at the edge of this circle for the helix to rotate, to locate in the right place. So, Control Z, get rid of that. One of the neat things about CREO, Control Z and Control Y work, same as in Windows, undo, redo. So, I'm going to add a plane so that I can actually sketch properly. So, let's find out where this plane should be. So we've got an offset of 72.12, let's just make that 75 to make life easy for ourselves. Hit OK. Now, select the plane that you want to base your new datum plane off. Then hit the plane command. So, given that you've selected a plane, it's nice and easy to locate. It just says, okay, I've got a plane, that gives me all the dimensions I need. If you remember back to stage 2 vector mathematics, it's basically just gone, well, x is equal, y is equal, z is equal, n is equal. That's fine. Basically, you've made two planes that are perfectly in line. One thing you can do, though, is you can increase the z value. So you can add an offset to the whole plane. Now, we put it 75 millimeters out to line up exactly with the center of those holes. So you'll see, here's the old datum plane, here's the new datum plane. Just hit OK. Old one, new one. New datum planes work exactly the same as old datum planes. Okay, now we can do helical sweep. Helix sweep profile. So we need a plane for the sketch. Select this plane, the new one. Hit sketch. Sketch view to make it easy. And now you'll see the line is where I need it, down the edge of where I want the thread to go through. Gonna hit accept. Okay, step 2, we want the helix axis, which fortunately we've got because we drew a cylinder. Because cylinders are based off circles, and circles are usually referenced off of a central point, CREO usually generates an accompanying axis whenever you create a new cylinder, even if it's a cylinder that you've cut out of something. So you see I've got one here from this larger object. I've also got a matching one on this other side. So, there's your helix axis. Step 3, create a sweep section. Again, you can see where the cross is. Sketch tree, that's what I'm looking for. So, let's create the section. It's a little bit tricky now. So what you've got to really remember is if I go into sketch view, I can't see the bore that I've taken out, but I can see this cross, which tells me basically where it's expecting the thread profile to be. So if I make a triangular profile, bear in mind when you do your actual designs, you're going to need to make sure you have the same shape on each. Not so important here because I'm just demonstrating how the mechanic works. Now, you'll see this actually projects into the shape instead of into the cavity. So if I hit OK to accept, you can't see anything because it's effectively done an extrusion into the shape. It's added material into where the pillow block already exists. But we don't want that. We want to remove material so that you can fit a thread in there. So if you hit the remove material command up here, this one, it's not like that. Okay. Troubleshooting time. The pitch is probably too small. Let's increase the pitch. There we go. So my triangles are a bit big. But you can see what I've done is I've basically cut the thread out of the pillow block. You can see the profile of it there. It starts and it goes down. If you want to get rid of this issue where your profile starts or ends inside of your object, what you need to do is your helix sweep profile needs to extend above the object. And then it'll start cutting before it gets to the object. It'll get to the object and cut smoothly. Anyway, if anybody has trouble figuring out how to do that, just message me and I'll make another video to show you. But really, you just make the first thing we look at, the helix profile, longer and extend it out past the end of the object. So now I've got a thread on one side. Threads are a bit of an annoying thing to do. They just take a bit of time. They're a bit fiddly. Sometimes they don't work for various reasons, like you saw there. My pitch was too small, so the threads would have been overlapping each other, and CREO just goes, nah, I don't like that. So I don't really want to do another one for this side, because let's face it, sometimes it's nice to be lazy in designs. Which is why the mirror command is fantastically useful. So making sure you've got helical sweep 1 selected, I'm then going to go mirror, select the plane here. So that's the midpoint plane. And you'll see the mirror has now been produced on the other side. It's been cut out in exactly the same way. Quick thing to note though, and you need to be careful of this, and this is why being lazy doesn't pay off. The hand of the thread has changed. So if you go to make a design and you decide to do this, you then need to realize that you're going to have bolts with different handed threads. It's a bit of a problem. There are ways to get around that. Easiest way is probably just for now, do it again, double check, make sure they look the same. If they have, you've probably done everything properly. Double checking is always good. But yeah, quick lesson there. Don't be too lazy with your designing. The commands are there to make everything easy for you, but if you're not careful, you'll end up with something like this, and you'll have gears that don't mesh. You'll have gears that don't even fit together. You'll have bolts that just don't fit. And if you ever go to cross-thread a machine in real life, you're probably going to get some tradies real angry at you, because they don't like it when you break their machines. Anyway, so yeah, a bit of a longer video. That shows you how to use a helical sweep though. A few little tricks. You've got the fillet, delete segment command, mirror. Just be careful with things like mirror. Okay, thank you.